All right, I just want to do a brief lecture just about the different ways that we can rig stuff. Like I said last class, I have all the rigging videos specific to the robot or the mech up on Canvas, but just to kind of go through what each one of these things are that we're going to be using so that you have a better understanding of what rigging is all about. So I'm going to start off with this. This is basically an item very similar to the stick animation that we did. I need to create some way to control all of these types of things. So if I were to just grab these and move them, everything moves, but when I go into rotating, you see that it falls apart. Okay? So as you start rigging stuff, we have to be very concerned with how things move so that we can create a system so that it works for us. Some systems are better than others, okay? I know that when basically I move this item below it won't move. When I move this item, when I move this item, this one won't move. When I move this one, that one won't move. But if I do it the opposite, I move this, that should move. If I move this, that should move, okay? So I'm going to basically create a parenting structure that allows all of these things to move in a similar fashion to our stick animation. So I'm going to grab this one, shift-click this, and parent it. Grab this one, shift-click that, parent it. Grab this one, shift-click that, parent it. Grab this one, shift-click that, parent it. Grab this one, parent. Grab this one, parent. Okay? So now if I grab this bottom platform and move it, everything moves. If I grab this circle here and rotate it, whoa, I should have done something first. Let me undo that real quick. I thought I hit a button, but I must have undid. There we go. I'm going to freeze transform everything. There we go. And then I'm going to do that again. There we go. All right, let's try this again. I move this, everything works, yes. I grab this bottom rotating piece and rotate it, and you'll see that everything rotates above it. If I grab this one and rotate it, everything rotates above it. And if I grab this one and rotate it, everything rotates above it. Okay? So this is a hierarchy. Everything that you animate will have some sort of hierarchy to it, where one item will control another item, will control another item, will control another item. Okay? So even like our arm, my hand's position is very much based off of how my shoulder is rotating. So my shoulder, in this case, would be the platform, and then my bicep would be, let's say, this area here, and then my forearm would be that area there, and then my hand would go into another similar type thing. So we have to know, obviously, how this hierarchy works. We also have to understand how things are going to move. This thing here, if I were to grab this and rotate it, that works, like I can rotate this, but it doesn't make sense of how it's working. This is obviously a joint. That's what's going to make this whole thing move, so that should all move all this stuff together like that. I also shouldn't be able to grab this and rotate it sideways because it makes no sense for that to rotate sideways, okay? Just like your hand, this joint at the very bottom of your hand can bend down like this, and it can go sideways a little bit. It can't twist. I mean, if we force it, we can kind of twist it a little bit, but typically it can't twist. This joint here, though, is basically just a hinge joint up and down, same thing with the very tip. So we have to understand those things when we go into rigging our stuff, okay? So we will be creating these types of setups on all of our rigs, regardless of if it's a organic one or it's a mechanical one. Another thing that we'll be aware of is where things are pivoting from. So this cylinder is in the perfect spot for where I wanted that to pivot from. As I modeled this, I was very aware of, as this thing rotates, it has to rotate perfectly on this cylinder, and so that's why I used it. I'm also aware of, as I modeled this, how far over this could go. That's as far as this thing can go. Maybe a little bit further, but that's pretty much as far as it can go. If it goes further, it's going to start intersecting this, and then that's going to look stupid. So we will not have that happen, okay? And the same thing the other direction, it can't go backwards because there's basically a lip right here that doesn't allow it to go backwards. If I wanted it to go backwards, I would have to have modeled it to allow that backwards and forwards motion, okay? So more stuff to be aware of on that front. This is not typically a good setup to use for rigging anything because I basically have to grab the actual pieces of geometry and move them, which could mean that I accidentally do something like that and break it, okay? Or I rotate it in a direction I shouldn't be rotating and now it's broken again, right? So that's why when I did the stick one, I use those curves because curves are very easy. I can lock all the geometry so you can't select any of it, and then you just grab the curves and move them, okay? So anytime we create something inside of our characters, inside of our rigs, we can create them a couple different ways. One is under Create Curve Tools, and you can simply use one of these. Typically I would use the CV curve tool. I would go into, let's say, the top view, and I would just draw out what I want. Okay, play with it for a little bit and you'll get the understanding of how that works. Okay, so here's R for robot. I can use this as my controller for all the stuff that I have. I can also go under Create NURBS and create a circle and use this as a controller for all the stuff that I have. It's not important what object you're using as your controller, just as long as you have something easy, recognizable that you can click on and move it around. You can also go to Type and, oops, sorry, go to Create, yeah, that was Type. There we go. And then we'll create this Curves from Type button. There we go. They changed where it was last version. So if I wanted, let's say, a plus sign, I could click this plus sign, hit Create Curves from Type, and then I would have a plus sign that I could then use as my shape as a controller. Okay. I could also go into Illustrator, make a document, doesn't matter the size, draw something inside here. So just for the sake of ease, let's go and turn that on. All right, that's beautiful. I'm going to combine all these. I'm going to delete half of that, and then just do this. For whatever reason, I decided that that's what I wanted my controller to be. Oops. Come on, there we go. So I'm going to take this and I would save this as, I'm just going to throw it on my desktop for now, controller. And I would save this as an Illustrator 8 file. If I don't save it as Illustrator 8, it won't come into Maya. Now I can just go to File Import, find that file on my desktop, and there's that curve. So I could create my own curve there, okay? So typically for some of the rigs, you'll see faces, you'll see letters, you'll see advanced shapes. Those arrows that I created for the stick, I drew in Illustrator and then brought those in to here. I also wanted the four-sided arrow that was drawn in Illustrator and then brought into here. You can create an entire sheet of controls, save them out, bring them into Maya if you would like, okay? I'm more concerned that you have some controls versus, these specific ones. So circles work fine. Don't use the square here. The square actually is consisted of 4 individual pieces, so don't use that. Do not use that. All right, so now the next part of rigging is being able to create connections. So if I have this locator here and I move it up and down, you can see how I've created a connection between how far the locator is moving versus how far this platform is moving. So now we have this thing that allows us to control one item with another item. Now this is, let me turn my grid off. This is a pretty obvious connection here where it's just moving it up and down. But I can also connect things like scale. So as I move it in the Z direction, you'll see how it shrinks in the Z direction. As I move it in the X direction, you'll see how it shrinks or grows in the X direction. So even though we're going to do one way of controlling something, doesn't mean we can't do a million other ways too, okay? We're never locked to just doing it in one specific direction. So let's see how we can create some controls. And these are just different ways that I would use to create controls. So let's say that I just wanted, as I move this up in the Y direction, that this moves up in the Y direction, okay? So anytime I do that, I have to be aware of what their current numbers are. This one's y is 0.186. This one's is 0.272. If I set them both, let's say, to 0 and 0, they're both in the exact same spot, okay? If I wanted to keep these exactly where they were and still use these values or still use those places, I would go to modify and say freeze transformations. What this does is it takes all that information that's there and it just gets rid of it, resets it back to 0, but allows these items to stay where they're at. So I hit that. This scales. That's not a big deal because this doesn't matter. But they're in the exact same spot, but their translate y is 0. This translate y is also 0. All right. So I'm going to go under Windows, General Editors, Connection Editor, somewhere inside here, right there. All right, this is the simplest way to connect something together. You have an output, you have an input, okay? Think of those controls on the stick. The output was the rotation of those curves. The input was the actual pieces of geometry, okay? So my controller is always going to go on this left side, so I'm going to say reload left. Whatever is getting controlled is going to go on the right side. I'm going to say reload right. Now it's simply a matter of just connecting A to B. What is going to connect what? So if I go down into this list, here's translate. If I click this, and I go in here and I find translate, click this, now I've connected all three attributes. So you see X, Y, and Z are all connected. If I grab this thing and now I move it, you'll see that it moves exactly the same way, like as this goes up and down. But it also connected it in the Z direction and the X direction, okay? Let's pretend I don't want that. I just want Y. I deselect that. I open this up. I just pick Y. I open this up, and I just pick Y. Now the Y works, but the other two directions don't do anything, okay? That will obviously be important because as we rotate stuff, we want the rotation to control one direction, but not all three directions, okay? Now, you can connect one thing to another thing. It doesn't matter. So I could literally connect translate Y to translate X so that as I move this up, it moves it over. As I move it down, it moves it back, okay? Sometimes you have these like weird connections that you want to make, and that's an instance where you might want that to happen, okay? So this creates a 1 for 1. I move this one up 1, the other one moves 1. I move it up 2, that one moves up 2. The next one I'm going to show is a different way. So this way I'm going to go into Node Editor. Where are you at? Right there. Node Editor. So let me clear this. That's obviously scary to look at. I forgot what the clear button was. All right, we'll just ignore it. There we go. So I'm just going to drag these items into the node editor. So here's number 2. I'm just going to middle drag this into here. Oh, he's already up there, so let me just find him. There he is. Come on. And my locator is also in here, which is right there. All right. So I have this one and that one. I've just drugged them into this area. By default, they come in like this. They're kind of all collapsed. If I open this up, and then I can see here's the translate, here's rotate, and here's scale, and then a bunch of other stuff. Very similar to what the connection editor looked like. This is a more graphical interface to see what's connected, okay? Whenever you drag something in, you'll typically get a shape node, which is what this is, and you'll get the transform node, which is what that is. This says shape, that one doesn't. That's how you know. I'm going to just open this up, and I'll make the exact same connection that I did before. So I'm going to open up translate, and I'm going to say, okay, this is the locator. Send your translate Y information to the translate Y information of that one. So now as I move it, you can see that it moves up and down like that. Okay? Now let's say that I didn't want a 1 for 1 connection. Let's say every time I move this one up 1, that one would move up twice as much. Okay? So I'm going to go to my create menu somewhere in here. It was there a second ago. Where'd you go? No. Show, no, just one. Where did my create menu go? Create bookmark, no. Here, let's do this. I'm going to remove selected nodes from the graph just to clear this off. There we go. No, there it is. Create node. Okay. So this button here, that's your create node on this far left side. I'm going to add a multiply. Okay. So there's a multiply divide node. And this basically is going to go between these. So what I'm going to do is I'm going to take this translate y, multiply it by something, and then send the result over there. So same thing, I'm going to open this up. I'm going to open up input 1, and I'm going to say translate y, go to input 1, y. And then here's the output right across from it. Send that result to this. Okay. So this goes into the multiply divide, then it goes into the cube. Then if I go to the attribute editor for that multiply divide, right now it's taking whatever number it's given, multiplying it times 1, and that's the result. So if I grab this and move it up and down, same exact thing. I can verify this is 2.6, this is 2.6. Now I'm going to go to the multiply divide and say 2. And so what should happen now is that as I move this down, apparently I lied, because that's not the right node. Nope. 3, yes. Into y, yes. Out of y, to y. All right, something's not playing nice. Hold on. This is like After Effects class all over again. Put that back to 0. Move this up. No, why aren't you playing good? This is 4. This is 4. Let's go back to the node editor. Everything should work here. This is the locators. Oh, no. Translate y, yes. Input y, output. Multiply, divide 3. All right, I'm just going to connect all of these to that same thing and then try it again. Nope, and nope. It's just being stupid. In a world where things work, that would work, okay? I would actually be able to move this up, and it would move up the other one the same amount. For some reason, my computer is not playing nice today, and it's not working, okay? So just pretend that that worked. It should work. Everything is correct. I'm never wrong. Let's just delete that and add that again. This. Multiply, yes. Translates. Just take this whole translate and drop that into there. Take this whole output and drop that into there. Okay, we get the same result. Yes, same result there. Now if I multiply times 4, now it's working. Weird. All right, so just wanted to be created twice just to make me look stupid. All right, so now as I move this up 2, this is going up, well, 2.7. This is going up 10.9, okay? So you see how it's using those same numbers as ways to change how it's going around those things. Sweet, okay? So this is a multiply divide. This is something that you may want to use. You may have something specific where you want to be able to move or rotate or scale something and not have to do it to the full extreme. Let's say you had an iris for a camera. You wanted to be able to very easily rotate your stuff, let's say 180 degrees, but you wanted each one of those blades to only rotate 10 degrees or something. You could just multiply it or divide it or whatever to do that kind of connection, okay? Now, I typically don't use the connection editor. I typically don't use the node editor. I typically use the expression editor. And this is probably one of the best tools that are inside here. Let me just delete that one. I'll delete that one too. I'm just going to drag this over here. And I'm just going to freeze my transforms. There we go. So I'm going to click on any one of these items. I'm going to go to Edit and say Expression. Now this is going to be confusing if you've never done any kind of expression writing before. I'm just going to type so I can make that bigger. The way that each one of these things work is the same thing. So you have the input equals the output. Okay? So basically that's all we're doing is doing the exact same setup with a mathematical formula. Okay? So in this case, my output or my input is going to be p cubed 9 dot translate y. Now notice the naming convention here. This is a lowercase p, this is an uppercase c, this is a lowercase translate with a capital letter y here. That name comes from this spot. That is exactly how it has to be typed. If any one of those are not exact, it won't work. Okay? Obviously that's frustrating to people who have never done it before, but trust me, this is a cool way to do this. So p cubed 9 dot translate y is going to equal, and just for demonstration's sake, let's just say 6. Okay, so now I go here, and you'll see that this block, its translate y, now equals 6. Okay, this is why it's awesome, because I just change one number, boom, and there it is. It just functions exactly like that. Now, I'm going to make this equal to locator 1 dot translate y. Let me make that smaller so you can see the whole line. There it is. So I'm taking p cubed 9's translate y, and I'm setting it equal to translate y of the locator 1. I hit edit, and now if I grab this and move it, you'll see we get that same exact connection. Now, that was obviously more complex than doing this, but imagine if we had 50 items here, having to go and load each one of those items inside that connection editor or node editor and draw lines connecting them, or reloading them and then clicking on stuff. Here I can simply switch this back to expression name. I can just change this one line, okay? And I can even have, if I put a semicolon at the end, I can have multiple lines inside the same exact thing. So I can make this one, let's say translate x is going to equal translate x. Translate z will equal translate z. And this one will be rotate y equals rotate y. And I've even gone into, let's say, Word or, just Word. And just done like copy, paste, replacement, all this other stuff. There we go. All right, so now I've set this up so that the translates all are connected and the rotates are all connected. Okay, so think of you have a character, you want his foot to move. We don't want to grab his actual foot geometry. We create a controller, and then we can link those controls to the actual foot. I can also go in here and just say times 5. Divided by 3, plus 3, minus 2. Okay, so now as I move this up and down, it's doing one calculation. As I move it this way, it's doing another one. As I move it this way, it's doing another one. As I rotate, it's doing something different. Let's say I divided the rotate by, or I multiply the rotate times 10. There we go. And I'll divide this one by 100. What? I'm not wrong. Times 10, yes. All right, I'm going to click on this little button at the end, script editor, and it will give me what the issue is. I've typed a W in the middle of this, right here. Cool. All right, so now let me scoot this down. So I added the rotate, so let's see rotate X. You can see I barely rotate this, and it's rotating like a lot, like crazy. If I go rotate Z, I'll rotate this a lot, and you can see how it's barely rotating. Again, that might be something that I want to happen. Imagine that I had a gear or something like that. I have something I want the character to like spin around 100 times, and as they're spinning it around, something is gradually opening. That's how we would do it. That is, like, look how crazy that is. I have to go to what? That far, just to get it to go 90 degrees, so 9,000. Okay, so this is what's awesome about this, and if I had different items connected, very easily I could update the entire list, okay? So expressions are something that you will play with when you start rigging. something to take note of also, when we set keyframes, remember the color that we had for keyframes that were over here? It was red or pink, right? And these are purple. Certain things inside Maya will give us color codes. Expressions is one. So if we see purple, we know it's expressions. If we see red or pink, we know it's keyframes. Let me delete that. Let's go to this next one. And then the last way of how we would get something to move, I'm going to grab this, grab whatever, and go to set driven. Now this is another area that you will play with. This is a probably the most confusing outside of expressions. But basically what we have being controlled is in this bottom window. What's controlling it is in that top window. So if I grab this and I load this as my driver, which is the controlling object, I grab this, load this as the driven, that's the controlled object, I can basically set things up. So I'm going to say the translate Y from this is going to control all of these attributes. Okay, I can pick and choose exactly what ones I want, but for now I'm going to just say everything. And I'm going to say key. Then I'm going to take the translate Y up to, let's say, 10. And then I'm going to do whatever I want with this. Rotate, move it over, scale it. There we go. And then hit key again. So now what's going to happen is, as I move that locator down, it's going to reset it back to where it was. So it's not just a one-to-one connection or some mathematical thing. It's actually figuring out how you moved it and then adjusting it along the way. So watch as I move this down. There it is. Very cool. And then I could even go like halfway through and do something completely different with it. I can move this, let's say, up here and then rotate it and then scale it up even bigger and then hit key again. And then do this kind of animation. No other tool that I've shown allows us to do anything like this. Set driven is the only way to get this kind of control over an item. So when we do things like rotating our hand, each one of these fingers has to rotate a certain amount. Sometimes it's going to be so much on this one, and that little joint. It's all different. So typically when you do a hand, a foot, something like that, you're going to use set driven. When you have a relationship-like connection, you can use expressions, you can use a node editor. You'll see these things all over the place. Okay, so that's the set driven. You'll see a lot more of that setup as we start playing. Now here's a couple of the things that we'll also be playing with is how things are connected to other objects. So this here is connected, and if you watch the definitions video, I went through these. These are the different constraints that we would use. Instead of going through an expression or going through the connection editor or any of that, we can simply grab two items, and under the constraint menu we can use these. Okay, so this first one here is a parent constraint, meaning, or a point constraint, meaning that as I move this, these items are connected. Is this one? Nope, this is a parent constraint. Okay, so as I move it, it moves with it. As I rotate it, it rotates with it. So those two items are connected. If I had a character, they had a watch on their wrist, I don't want the watch just to move with the character, I also want to rotate with the character as well. Okay, if he had a hat on, the same thing. I want those things to move together. If I have a controller, I need the controls to also move. When I rotate his arm like this, I want to make sure all the controls follow that arm as well. So typically I would use a parent constraint. This one is, let me make sure I have the right one. This one is a point constraint. Okay, so this one is just position, not rotation. This one is not position, it's just rotation. Okay, so that was point constraint for the second one and orient constraint for the third one. Sometimes you want one or the other. Like I mentioned in the video, under the parent constraint, you can really just specify translate or rotate or both. So these two are really not needed. This one is another one that we will probably use. What do I have selected there? Oh, two spheres, look at that. Which one works? Oh, this one's a scale constraint. Okay, so you may want something to scale with the other one. There you go. See that. And then this one is a point constraint. So this one is actually like that pyramid is pointing at the cone. Now we would use something like this for, let's say we have a character who we want him to look at a certain item. We would point constrain his eyes so that as that item moves, his eyes are also going to move too. It makes it a lot easier than grabbing two eyeballs and trying to rotate them to get them to look at something. We can just put that item there and it'll look at it, okay? Those are the basic constraints that you would use for your model. There's also a pole vector, which we'll get into eventually, okay? Now let's look at this right here. So this is a joint setup. We have a piece of geometry here, a piece of geometry there, and a piece of geometry here. Like I said, we typically don't like to control actual pieces of geometry by grabbing them and moving them. At all costs, we like to avoid that. Also, I don't like to parent stuff together. So if I were to take this and parent it to that, and then parent this to that, what happens is if I wanted to change the material on this one, it grabs the entire thing, and then I would have to go through and grab each piece individually. It's much easier to have these things individually connected, okay? That's where joints come in. So joints are just under this skeleton create joint menu. Typically you're going to be in a front view, side view, or top view when you do this. And as you draw them, this is what they look like. Let me change my color. Okay, now you can think of these exactly like we have in our body. We have a shoulder joint, an elbow joint, a wrist joint. All of those things are exactly like this. They're basically ways for us to give pivot points so that we can move and rotate and scale stuff. You may want to play around with the tool before you even get into actually creating it. I take my geometry and I parent the geometry to the joints. Okay. Now again, this is something that people will get confused with because usually they grab the wrong order. It's always geometry first, then the joint, and then parent. If you do it in the opposite order, it will break the joints. Here's the, for instance, here's my joint here, here, and here, and here. Let's say that I have a sphere. There we go, 3 spheres. Okay, I want to be able to take this joint and rotate it and have these 2 spheres go with it. The correct way is I grab the geometry, then shift-click the joint, and then parent it. If I grab this and rotate, it goes with it. If I grab the joint first and then the geometry and parent it, you can see that it just broke that connection to the other one. And when I grab this and rotate it, the sphere doesn't go with it. When I grab this and rotate, now the arm goes with it, and that's not how it should work. So I hit undo, I just reparent it correctly, reparent it correctly. Yes, yes, and yes. Okay. Also notice, this is the joint. They call that the bone, just like our bodies. You can grab the bone and it'll grab the joint above it. That's the best way to do it. Don't try to click right on the joint. It'll definitely work sometimes, but other times you have so much stuff kind of like in the way that it's hard to grab just that one thing. So usually I'll go to like a side view and just marquee that bone, which then gives me the joint. And I will delete that stuff up there. All right, so I parented this geometry to that joint. So now as I grab this and rotate it, perfect. Okay. Now notice how that cylinder is rotating perfectly around where it should be rotating around. If I'm over here and this joint is not in the right spot, and then I go through the trouble of parenting all the stuff in, and I forgot that one. There we go. And then I go and rotate this one, and I say, okay, that's good, that rotates perfect. I go to this one. You can see right away it broke. Okay? Your joints have to be in the exact spot you want them to be rotating from, otherwise that kind of stuff can happen. Okay? So we have to be aware of that kind of stuff. So that was parenting joints. These are skinning joints. Okay? This is, I have a single piece of geometry. I want to be able to manipulate that piece of geometry with using joints. So inside each one of these, I'm going to turn my geometry off for a second. I have a different selection of joints. You can see there's a lot of joints, there's a few joints, and then a lot of joints again. On the geometry, I have wireframe, there you go. These ones have a few divisions, these ones have a middle amount, and these ones have a lot of divisions, just so you can see what these things are going to do. So I'm going to grab both of these, I'm going to go to skin and bind skin. This is not a parenting thing because the geometry needs to flex. I'm going to make sure it says dual quaternion, which is the best one in the world. And we'll grab that. I'll do the same thing on these ones. This. Now we need to grab the top joint and then that piece of geometry and then hit that skinning thing, and now they're connected. And again, you can kind of look at the coloration. It colorized all the joints so that they're easy to see what joints are affecting what things. We'll get more into that later. So I'm going to grab all the joints here and then rotate this. Okay. I'm going to grab all the joints on the other ones too. So this one. I don't want that tip one, I guess. And that one's done. This one here. All right, so this is important to see because as you start modeling stuff, the amount of joints and the amount of points will play a pivotal role in what things will look like. This one on the far side has lots of joints, lots of geometry. If I click on this, you can see how many divisions it has. It's a nice smooth transition from the start to the end. Whereas on this side, we have a lot of joints, but we have very few actual things moving inside here. There's very few pieces of actual geometry. Right? And that looks blocky. This looks blocky. These here are in an acceptable range. Okay? Now if I click on this one and hit 3, that's as smooth as that's going to get. If I click on this one and hit 3, that one gets a little bit smoother. If I click on this one and hit 3, that's really smooth. And if I click on this one and hit 3, that's also really smooth. Okay? So every time you do something in these assignments, I go through and show you where to put them. But for future stuff, you need to know, if I'm doing a dog's tail, how subdivided does that tail need to be, and how many joints do I need to have along the way? It makes no difference or no sense if you have points here and you have a million joints in the middle of that. Those joints aren't doing anything. Every time you have a division, you can have a joint, but you just have to be aware that because we have a lot of joints, that we have a lot of stuff happening inside here. And you'll also see that this one is low divisions. We kind of lost the shape. It like went outside. This one has a lot of divisions. We need a lot of ways to control these joints, but that one looks the best, obviously. Okay, so just something to be aware of. Cool. All right, so that should be a good enough primer so that you understand, at least when we get into the rigging stuff, you know, you've seen it at least once before. When you get into it and start working with the mech rig and getting him to do his stuff, you shouldn't have too much of an issue. Just make sure that you're double checking where the joints are at, because those obviously need to be in the right spot. Make sure your connections are all good. Make sure your things are moving the correct way. Oh, one more thing I wanted to show was just adding attributes. So if we have a controller, we want to add attributes to this. So under modify, there's add, edit, and delete. You can figure out what those do, but add is the one that we're going to go to first. Anytime we name an attribute, you do a lowercase and then an uppercase. Okay, so the first word is always lower all the way, and then the second word and every word after that is uppercase. There's no spaces, avoid underscores, just keep it like that. This is called camel casing, and it makes everything nice and neat. The different kinds of data types, there's vector. We shouldn't need vector. Most of ours are going to be float numbers. Basically, it means it's a number, positive, negative, decimal point, whatever. Sometimes you'll use an integer, not for this assignment, and sometimes you might use a Boolean, sometimes you'll use a string or an enum, okay? An enum is basically a list. So if I have eyes open, eyes closed, I can have this basic list of things that are on. A string is just a word that I could store inside that's used for other stuff. Boolean is true or false, yes or no, like this visibility. An integer is a solid 1, 2, 3, 4. It's no decimal points. And a vector is a 3-digit number. So red, green, blue, if we were storing that information, or XYZ, if we were storing that, we could use those. Typically, you're going to use float for what we're doing for these assignments, okay? Oops, I closed it. I didn't want to close it yet. So let's just say we're doing like eye control. Lowercase, uppercase C right here. You would put a minimum, so what's the lowest point it's going to go, and then a maximum, what's the highest point it's going to go. For something like your hand, if I'm doing a single finger, it goes pretty far this way, and then it can go somewhat back. So I would basically have a positive and a negative value here. Something like my mouth opening, my 0 point might be my mouth fully closed, and 10 might be my mouth open. So I wouldn't have a negative because my mouth wouldn't go like into my head, okay? So again, you'll kind of see as you look at these of, okay, I'm making a controller for, let's say, the shoulder. The shoulder can go in this direction and it can go in that direction. So I'm going to have 2 different settings for that. So you'd have like -10 and you'd have +10, let's say. These numbers are also going to be connected to what you are controlling. So if you do have some dial that you want to be able to turn, you may want to set it to -50 and +50, or -20 and +20. -10 and 10 are just good numbers to start with, and then go from there. Very rarely would I do like -1 and +1. If you remember from the house example, some of those values were like limitless. You can go to anything, and some of them were very narrow. Okay, you want to have a good range to use. And then you just hit OK, and then you would see here's that eye control, and then I can use this. That's all it's for, is just to create it here, and then I can use that to control other things. Okay, like I showed with the set driven, with the expressions, with the connection editor, with the node editor. Okay. All right, so that should be a good enough foundation for when you go into the other stuff. Any questions on that stuff yet?